Hey y'all, this is Miss Smith coming to talk to you about balancing equations. And we're going to look at is it balanced or unbalanced and what does that mean for a chemical reaction. All right, the first thing I want to talk about is a chemical equation or a chemical formula. So remember, this is our chemical equation for photosynthesis and hopefully it looks super duper familiar. All right, I'm going to talk about why I have things color coded and what that means. All right, so on the left side of my equation or over here, remember, these are the reactants or what is combined to react. So in the case of photosynthesis, we remember that plants need CO2, which we give to them because we give out CO2, and they also need H2O or water. All right, our little arrow in the middle is kind of like our equal sign, or it means to yield or make something new. Because when we talk about chemical reactions, a chemical reaction must create something new. All right, that's like our nosy and our nosy city girls of their phone. A new substance has to be formed. And then on the right side of our equation, or in the red letters, these are our products or what is produced from the reactants. So we remember that plants are autotrophs and they create, that means they make their own food. So in this case, plants are making their own food called glucose. And we remember from 7th grade that glucose is a type of sugar. All right, we also know that plants give us O2 or oxygen. All right, so we're going to go see is this equation balanced or unbalanced? And I've broken it down into some simple steps for you to remember. All right, step number 1, write your elements below the arrow. All right, we're not just going to go write any random elements below the arrow. All right, we're going to go write the elements from our chemical equation. All right, so I'm going to go look for all the capital letters because capital letters are the letters that are found on my periodic table of elements. So I know that there's C. I know that that's carbon. All right, I see O. I know that that's oxygen. And then I see H. I know that that's hydrogen. So whatever is on my reactant side has to be on my product side. So on my product side, I also see C, H, and O. All right, there's some repeated elements, like there's another O over here and another over here. All right, I'm not worried about repeated elements. I just want to see how many elements I have. And I see that there's 3. I see that there's carbon, I see that there is hydrogen, and I see that there is oxygen. All right, so those are my 3 total elements in my chemical equation. All right, now we're going to move on to step 2 because we're trying to figure out is this equation balanced or unbalanced. All right, step 2 says work on the reactant side to count all the atoms of each element. So we came to you in another tutorial and we said, hey, there's a difference between atoms and elements. You have written your elements down below the arrow in our chemical equation. The number of atoms tells us how many times does that element appear in the equation. So let's go take a look. I see some familiar things. I see some big letters. Remember, our big letters are called our coefficients, and they tell us how many of that molecule there are. And then I see some subscripts. Subscripts tell us how many of that element there are, and they're the small letters. All right, so remember, this is kind of like math. So I told you, hey, go write yourself some parentheses to help you kind of divide it up. All right, there's 2 ways you can look at coefficients, the big number. I could either look at it as the distributive property, or I could say, hey, I have 6 CO2 molecules, and I could go write out 6 CO2 molecules. So if I could go write it out just like this. There goes 1 molecule of CO2. There goes 2 molecules of CO2. There goes 3 molecules of CO2. All right, I could write this 6 times because my big number, my coefficient says 6. All right, if I had a coefficient of 4, then I'd have 4. But this one's a 6, so I have to go write it 6 times. All right, if your brain works this way, that's great. Or if you're like Miss Smith, my brain totally does not work that way, that is totally cool because I'll show you another way. All right, so there goes 6 total CO2 molecules. All right, if I write it out like this, then I could go count the atoms of each element. All right, so I could clearly see that I have 1, 2, 3, 4, 5. I have 6 total carbons. All right, if your brain doesn't work this way by writing out all molecules, it's a distributive property. So I have to give the 6 to the C. Oh, and look, I have 6 C's, which is what I got whenever I wrote it out as well. All right, subscripts work a little bit differently. So whenever I distribute to a subscript or I give to a subscript, it's like works like multiplication. So I have 6 times 2, which gives me 12 oxygens. All right, or I could go count them over here. Here goes 2, 4, 6, 8, 10, 12. So I got the same answer either way. So whichever way your brain works is great. All right, the reason I wrote the 12 way over here is because I see, oh, I still have some more oxygen in this equation. All right, so here goes another coefficient. So remember to write your parentheses and do your order of operations. All right, so I have 6 H2s. So I have 6 times 2, which is 12, so I have 12 H's. All right, and then I have 6 times O. All right, and there's no subscript on O, so if there's no subscript, it means there's a 1. So I have 6 O's. So I have 12 plus 6, which will give me 18 O's on this side. All right, 18 total O's. All right, and that completes step 2 in our chemical equation. All right, step number 3. Work on the product side to count all the atoms of each element. That should be 18. Beautiful. All right, so we had 6, 12, and 18 on our reactant side. So now let's move to our product side and kind of figure out how many do I have on each side. All right, so I don't see any coefficients before the glucose molecule, so that means it's just 1. So I see that I have 6 carbons. I see that I have 12 hydrogens. I see that there are 6 oxygens here, but I also see, oh, there's more oxygen, so I'm going to go write 6 plus because there's more than 6. And then I see that there's another coefficient. Remember, write your parentheses and do your order of operations. All right, so we got to get rid of the parentheses. So this means that I have 6 O2 molecules. All right, so I'm going to distribute to the 2. All right, so 6 times 2 gives me 12. If that doesn't work for you, remember, you can go write out each one. So I'd have 6 O2 molecules. So here goes 1 O2. Here goes 2 O2. Here goes 3 O2 molecules. Here goes 4. All right, because remember, my coefficient was a 6, so I have to go write it 6 times. So if this helps your brain, don't work it that way. All right, so now I could go add up all the O2s. 2, 4, 6, 8, 10, 12. Beautiful. So 6 plus 12 gives me 18. Okay, and that completes step 3. We've done the reactant side. We've counted up all the atoms on the reactant side. And now we've counted up all the atoms on the product side. All right, step number 4. Look at each element to see if it is equal on both sides. Man, Miss Smith made some mistakes. So we noticed that there should be 18 oxygens. All right, so we're going to start on the carbon. 6 is equal to 6. Beautiful. Yes, it is. Is 12 hydrogens equal to 12 hydrogens? Beautiful. Yes. Is 18 oxygens equal to 18 oxygens? Yes. All right, so if I have the same number for each element, that means that it is a balanced equation. So this equation happens to be balanced, which is beautiful. That's exactly what we're looking for. All right, whenever we talk about a balanced equation, that means this. All right, the law of conservation of mass. So whenever an equation is balanced, that means matter cannot be created nor destroyed. We only changed it because remember, a chemical reaction means we created something new. All right, so I've noticed that we've kind of struggled with something that looks like this, all right, where we have these grams, and then we have some grams on the other side. Remember, when we talk about law of conservation of mass, we're talking about balanced equation. So whatever on the reactant side of our reaction has to be equal to whatever is on our product side. So for some of you, I rewrote it like this, and you were like, oh, I've got it, Miss Smith. So whatever is on the reactant side has to equal what is ever on my product side. So in this case, we're trying to figure out what is this question mark supposed to equal to be balanced. So I notice that I have 20.5 on this side, and then I have 32.7 and 17 on this side. For some of you, I also set it up like a math equation. So I have 20.5 plus x is equal to my 32.7 plus my 17. All right, notice in our equation there's plus signs. That means they added those things together. All right, so I set it up like this for some of you, and that seemed to help a lot of you. So then you just work your order of operations. So I'm going to work with 32.7 plus 17, and when I add those together, I get 49.7. All right, and that is equal to x plus 20.5. All right, remember, whenever we're solving for x, we want x by itself on one side. So I notice that this is a positive 20.5, so the opposite of addition is subtraction. So I'm going to subtract 20.5 from this side. So 20.5 minus 20.5 is going to give me 0. All right, so whatever I do to one side, I have to do to the other. So I'm going to minus 20.5 from this side. All right, and when I minus 49.7 from 20.5, I get 29.2. 29.2 grams. All right, so that's what X has to equal in order for this to be a balanced equation. All right. So in order to be balanced, it has to be, my reactants grams has to be equal to my products grams. All right, hopefully this tutorial helped you in some way. Have a great day.